سي بون دونك عسلامة مرحبا بكم الناس الكل. اليوم باش نعملوا لا بريزونطاسيون تاع تريمستر 1 pour le niveau Arduino 2. niveau Arduino 2 هو ثاني نيفو بماتريال اردوينو اللي هو باش نتعداو فيه حاجات افونسي في البروغراماسيون سيرتو باش نتعرفوا على دي فينومين فيزيك ولا دي برانسيب فيزيك كيما لا سينيماتيك باش يحكيو لنا عليها الولاد توا في البريزونطاسيون. باش نبداو اول واحد اللي هو سي ايوب بيرا. تفضل ايوب.
Hello, Mr. President, dear parent. We have the honor and the pleasure to present to you today our project. During this session and Junior Robotics Academy, we do a program of a robot working on the Artemis program. The Artemis program is a collaboration between a civil space agency worldwide with the goal of returning humans to the moon after they last stopped in the 1970s. The main goal of the program is to build a sustainable and permanent presence on the surface and orbit of the moon, similar to the constant human astronaut presence we have in the space station. To succeed in this program, NASA and partners have developed the transportation system for materials composed of several elements. The rocket to use is called the Space Launch System or SLS. This is it, which is capable of sending humans to space safely and support variety complex missions.
Bravo, Ayoub.
Astronauts will be carried in the Orion spacecraft, which is designed to be launched on the SLS and is capable of carrying and sustaining a crew of 4 people for 21 days, along with their energy, food, and water supplies on board. The Orion spacecraft is not designed to land directly on the moon surface. Instead, it will be docked on a human landing system orbiting the moon, which serves as a gateway between space and the moon. The gateway is equipped with a spacecraft called the lunar lander that we can describe like a space elevator to transport humans between the moon orbit and the moon surface. Our first mission is to contribute in the Artemis program or to deliver scientific experiments from the labs and load them in the SLS. These instruments are packaged inside a container. The robot has to detect the container and load it in the right slots.
برافو يعطيك الصحة.
To complete the mission, the robot has to search for the loading slot that contains 2 containers. There is 2 slots and only 1 full container to load. The robot should go to the first slot and check for the container. If it's there, load it and return to the base without checking the second slot. Else, the container is certainly in the second slot. So, the robot should load it from there and go back to the Artemis base. To make the programming easier, we use the concept of classes in C++. This concept allows us to create a GR-book library that contains all the programming methods necessary to activate the robot's feature without displaying long code in the main screen of the IDE. The use of this concept is called Object-Oriented Programming, OOP, that considers a part of the code that activates the functionality of the robot as an object that represents the robot itself. We can create several robots with the same function and program them differently. To minimize the redundancy in the code, the second mission for our robot was to deliver a CubeSat to be launched in the moon orbit. A CubeSat is a modular satellite used to establish a private communication network between objects far from each other. A CubeSat can be composed of 1 modular or more. Each module is 10 centimeter cube. Tunisia has developed and launched its first CubeSat in 22nd March 2021, which was named Challenge 1. The goal of this satellite is to connect smart IoT objects. Challenge 1 will be the first of 30 satellite constellation to be launched by 2023 in cooperation with a Russian company that manufactures CubeSat components. The robot will manipulate the CubeSat with its 2 degrees of freedom articulated arm. The arm is composed of a forearm actuated by a stepper motor and a gripper actuated by a servo motor.
Bravo.
To accurately control the robot arm without the need for testing for the angles of every position, we will use a complex physics concept called kinematics, which will allow us to calculate the exit motor angles we need to make the gripper move to a determined position. There are 2 types of kinematics calculation. Forward kinematics allow us to determine the gripper position using the motor angles of inverse kinematics allow us to calculate the motor angles of rotation using the coordinates of the gripper. In our case, the gripper will lift the object while being horizontal all the time, which means we only need to determine the height of the gripper from the ground that is slightly less than the height of the object to pick. If we determine the height of the gripper, we can divide it into 2 segments. A fixed segment, which is the distance from the ground to the axis of the stepper motor, which is equal to 110 millimeters. A variable segment, which is the distance from the axis of the stepper motor to the gripper, and it depends on the variation of the angle of the stepper motor. In order to calculate the angle of the stepper motor, we have to imagine a right angle triangle ABC, with A is the intersection of 2 lines, a vertical one passing through C and an horizontal one passing through B. To determine the angle ABC, we have the trigonometric function that says the sine of ABC is equal to the length of the opposite side of the triangle divided by the hypotenuse. Once we have the sine of ABC, we can use the inverse function to get the value of the angle.
Bravo.
When we having the angles, we can calculate the number of steps to command the stepper motor using the rule of 3 we learned before. To keep the gripper horizontal, we must command it to the angle ABC plus 19 degrees. When testing the program, we had a problem with the gripper wrapping the object when the arm is moving. Because of this problem is that we cannot move the stepper motor or the servo motor simultaneously, so we had to find the solution to synchronize their movement. In order to divide a large range of motion into many steps, we use intermediate variables to change the range of motion without losing the data while processing the function. The rate of the arm will increase or decrease with steps of 1 millimeter at a time, starting from the current position until it reaches the final position.
Bravo.
The synchronization is needed only when the arm is handling an object, and the calculation of lifting an object are different from the ones when lowering it. Corrected a function to manage the multiple types of movement. A function is considered recursive if it calls itself within itself. It's useful to avoid the use of loops for complex applications, which make the program much shorter and easier to understand. Now we are going to present to you a demonstration. Thank you for your attention.
برافو الولاد، يعطيكم الصحة. بريزونتاسيون ضحكونا برشا، وصلنا لان نيفو قوي برشا في العملات، قاعد نتحسنوا الناس الكل. براتيكمون وصلنا لنيفو بارفي، الناس الكل تحسنا برشا في المدة هذه في لي بريزونتاسيون. دونك هذاك علاش باش نتعداو الناس الكل للدوزيام سيسيون، باش نعطيكم توا لي زاتيستاسيون، باش نديكم بواحد بواحد باش نبداو حسب الترتيب اللي عملنا به بريزونتاسيون. دونك عندنا اول واحد سي ايوب بيرا، برافو ايوب، تصفيق عليك. بعد عندنا سي ابراهيم بوباكري، برافو ابراهيم، يعطيك الصحة. بعد عندنا سي احمد عكاشة، برافو احمد. وعندنا توا سكندر حضري، برافو سكندر. وتوا عندنا سي فاروق شماخي، برافو فاروق، تصفيق عليه. واخيرا عندنا سي محمد صديق حمروني اللي عملنا لا ديمونستراسيون، برافو محمد صديق، يعطيك الصحة، تصفيق عليه. تصفيق الولاد. باهي دونك يعطيكم الصحة الناس الكل، نكونوا هكا كملنا لا ديرنيير سيونس في الديمونستراسيون في التريمستر هذيا. باش نتقابلوا ان شاء الله في الدوزيام تريمستر من بعد العطلة، أول ويكاند بعد العطلة اللي هو يجي ل 9 جونفي إن شاء الله. على بروشين.